So Stephen Porder is the Acacia Professor of Ecology and the Associate Provost for Sustainability at Brown University. Stephen, thank you so much for taking the time to talk today.
My pleasure, Joe. Thanks so much for having me.
So I'd love it if you could start by just telling the audience a little bit about your sustainability journey.
Sure. I have a very sort of wandering path. I was a history major as an undergrad. I got a master's degree in geology, and I eventually found my way into an ecology PhD program where I studied tropical rainforests actually, and the sort of the way that they grow and what constrains their growth and how that might change in the future. And I worked for about 15 years in what I would call basic science, trying to understand the flow of nutrients and energy through a forest, which sounds very esoteric. My field of expertise was actually called biogeochemistry, which is probably the most off-putting name you could have. But biogeochemistry essentially got its start in farming, right? And the reason is that if you are a farmer and you want to grow a crop, you need to understand the biology of the plant and the geology and chemistry of the soil in order to get your crop to grow as much as you want. And so from that, we've expanded that idea into like, well, what makes a tropical forest grow the way that it does? Or what makes a prairie grow the way that it does? Or what makes the tundra grow, function the way it does? So I worked on that for about 15 years. And I began to think that what I was doing, although it was fascinating, was not really addressing the challenges that I wanted to be addressing in the short term, which is how can we build a more sustainable society based on a scientific foundation and understanding of how the world works. And so around about 2016, 2017, I had the opportunity to begin helping my university write and think about what its priorities were in this nebulous world of sustainability. And I know we're going to talk a little bit about what sustainability means to me. But at the time, we all used that word, but none of us had really at the university sat down and sort of defined what we meant by it. And so Brown was, thoughtful enough to create a position. I think it was the first in the world at the highest sort of level of administration, which is the provost's office, that tried to think about how should the university be acting in the world of sustainability? What should we be doing? What should we maybe not be doing? Because you can't do everything. And so for the last, whatever it is, almost 8 years now, I've been part-time professor, grad students, teaching, writing papers, and part-time helping the university and our city and our state and other universities think about the transition to sustainability. And so I sort of sit in both the ivory tower world of academia and the sort of real world of making a transition from what we're doing now to what we could be doing with more benefits and fewer impacts.
That's really interesting, and I want to dig into a few different things that you mentioned. But first, as you mentioned, I want to talk about how we define sustainability. Can you talk about how you think about sustainability and the frameworks you use to think about it?
Sure. So sustainability, of course, means lots of things to lots of different people. And the way that I approach it is one very much of a physical scientist and very much and biological scientist, and one who has an eye on both the past and the future. And let me explain what I mean by that. So in order for an organism to succeed on this planet, humans or any other, they need to have access to energy and food and water. That's sort of a baseline, right? And so if any organism wants to persist into the future, they need to continue to get energy to reproduce themselves and food and water to build the machinery of their bodies. And so we're no different, right? We have a few differences. We have lots of other things we use energy for example, cars and buildings and airplanes and this computer conversation that we're having, right? But basically we need energy, food, and water. Now, that's a floor. We might very well want other things in a sustainable society, like equity and justice and fairness and lots of other things that are really, really important. And I certainly wouldn't argue that sustainability does not include those things. But if we don't have access to energy, food, and water at a baseline, then we can't have any of those other things either, right? And so I sort of take the approach in my own work of how can we transition our society to getting those basic things, energy, food, water, in a way that does not harm us or preclude future generations from doing the same. And that's not to say that there aren't other components of sustainability, but again, I'm really focused on this floor. And so what does that sort of translate to in the modern day? It means not changing the atmosphere, the land, and the water so much as we're getting our energy, food, and water that we can't continue to do those same things in the future with great success. So that's sort of how I approach it. Again, there's many, many ways of approaching it, but that's where my expertise merges with the definition of sustainability.
So within that framework, the thinking about how we transition to a sustainable future, the implication in just that statement is that we are currently not on a sustainable path. We're currently not we're not thinking about energy, water, and food in a sustainable way. How do we or how do you think about changing behavior at the individual level, the organizational level, as you're in your role as the at Brown, and then also maybe thinking at a macro society level? How do you
Yeah.
think in those three contexts?
Well, before I answer that, maybe I can talk a little bit about a little bit more about why I've come to this idea of energy, food, and water as a fundamental thing. So first of all, my scientific training is in a field that thinks about energy and food and water a lot. But if you look back through the history of the Earth, so Earth has been around for a really long time. It's been around for 4.5 billion years. We think life has been on this planet for most of that time. And even though life has been here for, let's say, roughly 4 billion years, that's a really long time, there actually aren't that many organisms that have fundamentally changed the world. It's a very rare thing in that vast, vast, vast expanse of time. It's very rare for an organism to change the world. For example, dinosaurs, which are maybe people's image of the most sort of impactful thing in the geologic past, right? We all grew up hearing about them or seeing them in a museum or whatever. Dinosaurs had almost no impact on the planet whatsoever. They left some bones behind for us. They're very big. They're cool. Nothing against dinosaurs. But like they didn't really do much, right? So there are a few groups of organisms that have really changed the world. Way back when, about 2.2 billion years ago, a group of bacteria in the ocean actually oxygenated the atmosphere. So they actually provided the oxygen that we breathe today, or the first wave of oxygen that continues to exist today. And so if you and I had been there before those bacteria changed the world, we would have suffocated instantly. We would have been in no oxygen, right? Can't live without oxygen. The next group of organisms that did this is actually the plants that evolved onto land. And this was before the dinosaurs, but way after those bacteria. And they also sort of profoundly changed the atmosphere and changed the world. The reason I bring those two up is that both of those organisms were able to make those changes because they fundamentally changed how they got energy, food, and water. That is, they evolved new ways of doing that. And as a result, they accidentally, and I put accident in quotes because I don't ascribe intentionality to them, but a byproduct of their success was changing the atmosphere and the chemistry of the planet. So that should, I think, begin to sound a little familiar here. Like humans have dramatically increased the amount of energy that we use. We've dramatically increased the amount of food that we have available to feed all of the people we have. We've dramatically changed the amount of water and where it is on the planet. So for example, there's 3 times more water in reservoirs than there is in all of the world's rivers. And we've actually measurably changed the amount of rain that falls on our continents by moving water around. So like, it's amazing because there's a lot of water on this planet. Remember, the ocean is 70% of the surface. And even still, we can detect the human impact on water. So it shouldn't be surprising then that we're changing the planet dramatically if we're having this huge effect on the flow of energy and water and nutrients. And so moving into the future, what can we do? Are we stuck like our world-changing predecessors, sort of with these negative consequences? And the answer is no. Because we have the ability to choose where we get our energy from and to choose the outputs and manage the outputs from our food and water use, we have the opportunity to get what we need, energy, food, and water, without the negative consequences that our world-changing predecessors sort of had to live with by virtue of their own success. So you asked me a question a long time ago, and I went on kind of a tangent, but it's not a tangent because what we need to do as individuals, as institutions, as a society, is to provide for us, for all of us, access to food and energy and water, while wisely managing the unintended consequences of our getting it. And fortunately, over the course of my career, I got my PhD in 2005. Over the course of my career, we've seen a transition from that sounding like a pipe dream to basically us having about 75% of the knowledge that we need in order to get there, which is amazing, right? Like, I mean, we're not 100% there. There's lots of challenges. But if you take a look at the last 20 years and say, wow, we went from that being a nice thing to think about to us basically having the technology we need to do it in 20 years, that's kind of amazing. Do we have a long way to go to implement that technology? Sure. But still, that's a lot of success.
Yeah, I appreciate you giving more background. I want to ask you about a couple of the words that you used, the intentionality that you mentioned. Thinking about those our predecessors, there wasn't any conscious decision to do or not do something, right? So how do you think about this moment where we're in, where we are, for that 75% of solutions that we have, some of them we're not doing in a lot of places, and some of them we're starting to do more of. Like, how do you think about that notion of intention?
Yeah. So life is messy. Humans are messy. Politics is messy. And people have lots of different priorities. And that's sort of, that's always going to be true. And I don't have any illusion that this is going to be easy. But let me give you a few sort of simple examples. Okay. I'm going to start with my own home. So when I bought my house, so I live in Rhode Island. I live in a house that was built in 1920. It was sort of 1920s suburban sprawl in Providence, Rhode Island, where my university is. It's a 4 square, it's a box. It's 2 stories tall. Looks like a regular old house, about 2,000 square feet, right? So kind of a regular-ish house. Had an oil furnace, no air conditioning, and we had a gas car, 2007. So one of the projects I undertook was so what do I want out of that house and out of that life? I want a warm house in the winter. I want a cool house in the summer. I want a car that I can get places when I need to go places. That's basically what I need my house for, right? And a stove to cook on and hot water. So about the mid 2010s, so 2014, I decided, well, the house was in pretty bad shape. And I didn't want to fix it up before I got tenure. So I finally got tenure and decided we were going to fix up the house, maybe renovate the attic and turn it into a bedroom for make more room. And as part of that, we put in a bunch of insulation. We ripped out the oil furnace. We put in heat pumps, which are efficient electric-driven machines that essentially move heat from one place to the other. So your refrigerator is a heat pump. It pumps heat from inside the box out into your kitchen. Your air conditioner is a heat pump. It pumps heat from inside your house and puts it outside. So it's sort of pushing heat the way it doesn't want to go. We put in heat pumps that not only air conditioned in the summer, but we're able to warm our house in the winter. So they're pushing heat from outside where it's cold into the house to make it warmer. We switched to an electric vehicle in 2019. And as a result of that, the amount of emissions from our house, including our car, dropped by 80%. And that includes all of the electricity, that includes the electricity we're consuming. So that electricity is being made at a power plant somewhere. We're counting those emissions. So what do we have now? We have a house that's warm. We have a house that's cool in the summer. We have a car that drives us to work and back and forth and on trips and whatever. In fact, the house is way more comfortable. We spend about half as much money. and we emit 80% less fewer greenhouse gases, and therefore have reduced our footprint on the climate. There's nothing about our house that is worse than it was before. It's actually better, right? Now, you could say, well, Stephen, you're a professor about climate and you know all this stuff, and you're relatively wealthy compared to the vast majority of people in the world. And I would say, yes, that's absolutely true. That's why the wealthy should go first. Like, just like the first people to get iPhones were not the average person, and now everybody has an iPhone or the equivalent, a smartphone of some kind, right? We shouldn't take the fact that it costs a lot for the first movers to indicate that it will always cost a lot. And I'll just sort of highlight the idea before we go on to the next point. Like, if you look, for example, right now in China, you can buy a 7-person SUV made by Toyota, fully electric, for $15,000.
Mm.
Right? So the reason we don't have that here is political, not technological. And so, yeah, of course, the first electric cars were very, very expensive. The first solar panels were very, very expensive. The first batteries were very, very expensive. And those costs are plummeting, as you would expect for a technology that gets more mature. So you can make those changes. And actually, those changes can be made all across society, and they're being made in lots and lots of places. So yeah, we can, I don't know if that answered your question, but that's a little.
Yeah, and I want to follow up on that, thinking about consumption patterns as well, and thinking about how the United States has a very significant greenhouse gas footprint, partly due to the amount that Americans consume, and that seems like more of a maybe not intractable, but a very tough challenge to uh, get people to consume less,
Yeah.
and change those types of behaviors.
Yeah, and so I would say that this is a big debate, right? So there are a lot of people out there who say, oh gosh, if we're going to have a sustainable society, we need to just consume less. Like, there's no way to do it if we can. Uh, that might be true. I have colleagues here at Brown who say, until we overthrow capitalism, we'll never solve the climate problem. Personally, I don't really want to wait to see how that plays out and let climate change keep going. Whether or not you think we should overthrow capitalism, no one's overthrowing capitalism in the next couple of decades, and we need to fix climate change like right now. So, because the atmosphere is continuing to heat up, and I don't want to talk just about climate change. I'd love to talk a little bit more about food and water as well. But for now, like, we don't have time to form the perfect political system in order to fix this problem. But let's go back to what you said about consumption. At the personal level, I have not changed my consumption of the goods that I want. Like, my house is just as warm. I drive my car just as much. I eat just as much food, like all those things. But my impact for that consumption has dropped by 80, or actually, if you count the renewable energy that I now produce, by basically 100%. Right? And so, yes, it would help if we consumed less, for sure. I am not super optimistic that we're going to convince people who are used to consuming a lot that they're going to consume a lot less. But even if people continue to consume at roughly the amounts they're consuming, we can go a long way on this problem by changing the impact that consumption has. So we can, for example, and this is more true for global climate change than it is for food, for example, and I'll talk about that in a minute. But like, you don't need to stop driving. You just need to drive an electric car and charge that car from renewable electricity, and you've eliminated the vast majority of the carbon footprint of that car. You don't need to not heat your house. You just need to heat your house with heat pumps and run those heat pumps off renewable electricity, and you've reduced the impact of heating your house. You don't need to sit in the cold, right? Another great example of this has already happened. We used to use incandescent light bulbs. We now use LED light bulbs. We still have lights in our house. We use about 90 to 95% electricity to produce that light, right? So people want the stuff they want, but we can change the impact of that stuff. That doesn't mean that it still wouldn't be better to have one less light bulb, or to, whatever, insulate your house better. All of those things are really important, but it doesn't have to be only that. I think there's one of the things that people it's kind of interesting. So I got this job as provost for sustainability, and when I go meet with, say, a team in athletics at Brown, I walk into the room and they're all looking at the ground and they're like, he's here to yell at us about how much, how much we throw out, or like that we don't recycle. And everybody always comes up and is like, I have a confession, or please don't yell at me, but I brought, I usually bring my lunch, but today it's in a plastic. I'm like, I don't care, like, relax. One of the things I try to do is say, let's focus on the big buckets, right? Like climate change is a big one. So let's reduce the impact of the cars that we drive, the way that we heat our house. And let's not worry about whether you got a straw or not. Like, it doesn't really matter. um, and so it's not, I don't think people should be feeling guilty. I think people should be feeling empowered to make transitions that really matter.
So I think that's a good transition to talking about food. One of the things I heard you say was it's a little bit about the energy that goes into the products and how like changing the impact of the product. So you're thinking about like the same way you talk about your house and switching the amount or changing the types of energy that powers your car, your house. You're changing the types of energy that create a product. For food, is it just about the energy available to make that food? You also mentioned in your introduction the biogeochemical understanding of sustainability.
Sure.
So with food, it's a lot more than just the energy, right? What are the
Oh,
dynamics associated with food?
so food's a really complicated one, and there's a lot of dynamics. So the major impacts that result from our food. So first of all, food production is the single biggest land use that humans have. We use about 50% of the ice-free surface of the planet to produce food. So if you add that up, that's the size of South America and plus the size of Africa, just to give you a sense. That's a huge amount of land, right? Well, what is that land used for? Actually, relatively small amount of it is used for actually growing crops. The vast majority of it is used to grow animals.
Hmm.
So if you split it out roughly, we use about South America to grow crops and about Africa to grow animals.
Wow.
Okay. If you look then at what we use our crops for, many of them, especially in the US, are going to feed animals. They're not going into human mouths, right? So with that background in mind, what is the impact of food production? Well, in order to grow crops, you need water. So about 70 to 80% of all human water use is for agriculture. And you need the nutrients that make those crops grow, particularly nitrogen and phosphorus. And those nutrients, when they go into the crops, help the crop grow, but when they go into the environment, cause all sorts of problems. And I'll highlight nitrogen as one of the two. I work a lot on phosphorus as well, but just for now, nitrogen, when it escapes from the farm or goes off the farm and into our mouths and then into the environment after it goes through us, causes global warming, causes smog, causes acid rain, causes the destruction of stratospheric ozone. If it's in really high concentrations, it causes cancer if we drink it. So like there's all sorts of problems when it escapes into the environment, but we really need it in order to grow our crops.
Hmm.
So unlike fossil fuels, for example, like you can run your car without gasoline and still have a car. You just have to run an electric car. There's no substitute for nitrogen. We need nitrogen in order to grow our crops. And so the game there is how do we keep it from going where we don't want it? How do we keep it where we want it to grow our crops and not where we don't want it in the water, in the air, in the river downstream from the farm? There are very practical things people can do. I have a colleague in Iowa, for example, who has brilliantly come up with this idea to plant strips of native prairie sort of across the gradient of farm fields. So the water is going downhill and the prairie strips are blocking the water from going downhill. And that prairie reduces the amount of nitrogen that reaches the river by about 80 to 90%. It's
Wow.
only a small fraction of the farm field, so the farmer doesn't lose productivity. It's just an innovative solution and in fact helps rebuild the soil that farmers are losing to erosion.
Hmm.
So there are sort of on-farm strategies we can use and deploy, and these are being deployed, not as widely as they should be yet, but more and more. There's precision agriculture where we can actually use highly sophisticated sensors to see, does my crop need more nitrogen right now or not? In the old days, you would put it on and just put on so much that there was enough and a lot got lost to the environment. But we can be more precise about that. We can time when we put on the nitrogen. We can sense whether the plants need it and titrate a little bit better. So
Hmm.
there are all these strategies we can employ so that we keep growing the food that we need without losing that fertilizer off the field where it does harm. But I do have one piece of sort of not good news for the average American diet, which is there really isn't a way to have sustainable agriculture and this many cows.
Hmm.
So the vast majority of the crops that we grow in the US, not the vast, a large fraction of the crops that we grow in the US are going to feed animals. The vast majority of deforestation in the Amazon is going to clear land for cattle. So the production of meat from animals, particularly ruminant animals like cows, is sort of a fundamental barrier to sustainability. We need to think very seriously about. It doesn't mean that everybody has to be a vegan. It doesn't mean that everybody has to even stop eating red meat, but we need to eat much less of it.
Hmm.
Or we need to get that red meat from something that isn't a cow. Like if you think of the cow as the meat production factory, right? It's an incredibly inefficient meat production factory. And maybe there's a way to make meat without having a cow. But
Hmm.
right now, we're relying on a 10,000-year-old technology, which is a cow, to produce this meat for us. And that is not sustainable for the number of people that we have on the planet or the amount of meat that we're eating. And so we are going to need to transition diets. Actually, we've seen this already. If you look in the United States, per capita red meat consumption has actually been dropping my entire lifetime pretty much, and it's being replaced. So but the amount of meat we're eating because our population has grown is still going up. So, or is still high. So anyway, there's a lot of good news on the agricultural front. I would say but not perfect. I would say that fixing agriculture is probably going to be the hardest piece of the sustainability puzzle. Uh, it's a challenge. We don't have as much knowledge as we do, for example, in the energy sector. Um, but that doesn't mean it's impossible. We can make radical improvements and keep learning as we go. We don't have the privilege of waiting for the perfect solution.
Hmm.
We have to be moving as best we can, and you're seeing this with innovations in all of these spaces. And I don't have so much hubris as to think that we know the perfect answer here.
So with regards to nitrogen, is it the case that the nitrogen that is running off of farms is still has value to the farmer? Is it something that is it a resource that could be like if you think about resource flows in an economy, is there a value to trying to get that resource back and reuse it in a uh, at scale?
Yeah, so not really because it's cheap enough to get new nitrogen,
Hmm.
but it's much more expensive to pull it back out of a river than it would be to just go buy another bag of fertilizer.
Hmm.
And there's the labor costs, and when you have labor to put it on, it's so the place where we could really, um, the place where the recapturing of nutrients would be really helpful is from, for example, sewage or compost, right? Like those places are highly concentrated in these nutrients and could be reused. But and this is where the technology is challenging, right? Like there are other concerns about, for example, using human sewage as farm fertilizer, right? Because there's
Hmm.
not just nitrogen or phosphorus in there. There's all sorts of other stuff that you might not want to put on a farm field. In fact, we have regulations in this country about not using human sewage on, even if it's composted. And so, this is where innovation and challenges arise. But let me just back out and say there's a huge amount of room for improvement. So, let's imagine that you're a farm field and you put on 100 units of nitrogen onto that farm field, and you follow that through the crop, through the transport, through the food that's lost through harvest, into your mouth in where do you live, Joe?
Just outside DC.
Okay, so here we grew this corn in Iowa and we put on 100 units of nitrogen and it ends up on your plate, which is very unlikely because almost none of the corn we grow in the US ends up in human mouths. But let's just imagine that you're the oddball and you got the one piece of corn that does. Only 14 units of nitrogen, we put 100 on in Iowa, only 14 units of nitrogen enter your mouth.
Mm.
The rest has been lost along the way. And that's if you're a vegetarian. If you're eating a piece of steak, then only 4 units of nitrogen that we put on the farm field end up in your mouth. Now, you need that nitrogen. That's how you build proteins in your body. But that's a pretty inefficient system if you lose 96% along the way. And then when you go to the bathroom, it goes out the other end, right? And we don't even get that back. So there's a lot of room for efficiency improvements here. Sucking it back out of the river is probably not the right answer. Probably the better answer is keeping it out of the river in the first place by doing things like reducing the amount you till, planting cover crops, planting prairie strips where appropriate, as I was talking about before. Farmers are losing soil off their farms, and that soil is taking nitrogen with it. And anything we can do to improve our practices, and I just mentioned a few things, will dramatically help with that problem.
Yeah, you mentioned I think it was like precision
Yep.
farming. Is part of that integrated into like vertical, like urban farming solutions that are coming up, or is that something different?
Yeah, I mean, it is different. And I personally like vertical farming, in my opinion, is kind of a niche idea that has no scalability, to be quite
Mm.
honest. So if you want like fancy microgreens for your fancy neighborhood and you want them grown in a vertical farm outside your city, like fine. But remember what I said, we use half of the Earth's surface to farm and raise meat. And in contrast, all of the cities and roads in the world make up 1%,
Mm.
right? So you're going to vertical farm. Okay, let's say you have a 5-story tall farm and it's the footprint of a big building. Like, if you've ever driven across the Midwest of the United States or any other major agricultural area, like, it's just mind-boggling how much food we're producing. We're just using so much land. And
Mm.
so you're never going to have vertical farming be more than a niche in terms of food production. Like, it's just, I don't care how big your buildings are or how tall they are, they're not like a third of a continent, which is what we're kind of using to grow food in the U.S. as an example. So, it's certainly fine for growing tomatoes or whatever. It's sort of, to me, a little bit like people are like, oh, well, we should have backyard gardens, and I'm like, okay, and how many calories do you get out of your backyard garden? Even if you're a great gardener, you're going to the supermarket pretty much just as much. And maybe you get your tomatoes from your garden and they're delicious, and I do that too, and I love them, but it's not a solution to the agricultural problem.
Yeah. Well, I also want to talk about water, and maybe this also relates, but the just thinking about water in a few different ways. There's thinking about like the rivers and the runoff you were talking about. There's thinking about the water that we drink and how we use that. And then I'm also curious about I don't know if this is direct uh like if the dynamics are directly impacting oceans as well, but also curious about um, ocean dynamics and what do we need to be thinking about when it comes to water?
Yeah. So, of course, the oceans have the vast majority of water on the planet, and it's salty. And I'll come back to that in a minute because I think there's some interesting things there that we're just beginning to understand. But in terms of fresh water, the water that we all need for crops, but also to drink, right? There's sort of two major pools of it. There's surface water, so rivers, right, and lakes that are fed by rain. And then there's water stored underground, so-called groundwater, that's stored sort of like in the pore spaces in rocks and in sediments underground. And so you can think of that water as sort of being stuck in a sponge, and those are called aquifers. If you look, you can actually measure from space, like amazingly enough, you can measure how much water is in aquifers from space by detecting the gravity, the changes in the gravity gravitational pull of the Earth as satellites go around. And so the satellites go around, and if they dip down a little bit more, there's more water down there, sort of pulling on it. And if there's less water, they don't dip down quite as much. And it's amazing that we can measure it. It blows my mind, but we can. So what we see from that, unfortunately, is that in a lot of places we're mining water. And what that means is we're using it up from aquifers, from these underground storage areas, more than is being refilled by rain, right? So if you imagine rain falls, some of that water goes off in a river, some of it sort of percolates down and replenishes this bank account underground, this aquifer. And if you suck out more water than comes back in, then the amount of water in the aquifer is going down. The biggest aquifer in the United States is in the central US is called the Ogallala. It sort of stretches all the way from the upper Midwest down through the north end of Texas. And what you're seeing in the Texas example, in particular, where the aquifer is pretty thin, is that it's just being sucked dry. So you're having to drill deeper and deeper and deeper to get the water, and eventually that water will just go away because we're using it up faster. So that's a real challenge. And then on the surface water, as I think I mentioned in the beginning, like we already dam up rivers and put things in reservoirs in enormous amounts so that so that we can use that water. And the vast majority of water use is for agriculture, is to grow our crops. 70 to 80% of the water that humans use is not for us to drink, but for plants to use. So how do we fix that problem? Well, let's go back up the chain. The first thing we can do, again, is to use less meat. And the reason for that is that we are feeding our crops to the animals, and that's very inefficient. You could probably feed 10 people. If the people ate the crops directly, you could feed 10 or more people than the same amount of food you would get from that cow. So that's a big hit you're taking. So that's more water you have to use to grow more crops to feed those animals before the people eat them. So that's one thing. We could change the way that we irrigate. We could do that more smartly, right? So we could be very water efficient. And there are ways to do that. It's not rocket science, but it's important. The barriers are cost and sort of legal frameworks and incentives and all the same things that hinder transitions. But we know how to do it. It's not technologically impossible. And then I want to come back to the oceans because the oceans are basically an unlimited amount of water. The problem is they're salty. And so a lot of places are beginning to look at desalination technology. This is happening in the Mideast, for example. People are also looking at reusing sewage water. So Los Angeles, for example, purifies sewage water and puts it back into the drinking system. It's totally fine. Like, we know how to clean water. It's not. And so the challenge there is energy, right? If we have enough energy, we can desalinate water or clean water and recycle it much more efficiently. So let's go back to the beginning of the conversation. Right now, most of our energy comes from burning fossil fuels, and that's inadvertently causing climate change. But yet another reason to switch to renewables and to non-polluting sources of electricity is that if you had enough of it, you could use that electricity to clean up as much ocean water as you wanted and solve the water problem if you had one. So, there's, again, the thing that I mentioned about farming and biogeochemistry at the very beginning, which informs sort of the way I think about the world. It's not like energy is separate from nutrients, is separate from water. If you're going to manage a system wisely, those are the things you have to manage in concert. And that's true for our food production. It's true for our energy production. We need to be thinking about these major things: energy, food, water, how they're interconnected, and how to manage them in a way that not only produces what we want, which is lots of energy, food, and water, but mitigates the consequences that we have no interest in. We don't want to put CO2 into the air. We don't want to put nitrogen and phosphorus into our rivers. It's a waste of money, actually. It's totally useless. In the case of climate change and CO2, it's actually harmful. But we want the energy, and we want the food, and we want the water. So the beauty of where we are right now is we're beginning to figure out how to get those things we want without the bad side, right? And so when I hear people say, we can't do this, it's too hard, I'm always stunned, because they're often the same people who believe in innovation, who believe that we can do anything that we put our minds to. And I think what they're maybe really saying is, I don't think it's important, or I don't think it's really a problem. And I think they're right to not think it's a problem. I happen to vehemently disagree. I think it's the biggest problem humanity has ever faced, to be frank. But we can do it. Like it's not beyond the scope of human ingenuity to figure this out. In fact, we are figuring it out as we speak. And what we haven't figured out yet is how to bring everyone along to the idea that this is worth doing. But it's not like we can't do it. And so I'm actually very optimistic that we can make the transition that we need to make. Um, and I wasn't 15 years ago. Um, Whether or not we will be the question of the rest of my lifetime. And I figure I'm just going to try my hardest and hope a whole bunch of other people try their hardest too and see where we get.
Well, I think that's a good place to stop with an optimistic outlook towards the future. Uh, I really appreciate you taking the time and sharing your insights and wisdom, and hopefully we can continue the conversation down the road.
I'd be happy to. This was great. Thanks for having me on.